Today we are on Unit 6, Module 3, Session 2, and this one is called Data Analysis. So today we will study the line plot that we completed in the last session to consider range, median, and mode of the data. So I'm going to talk specifically about what those terms mean in the following slides because those are basically the key of our lesson today. We will add and subtract some mixed numbers with like denominators. We will make a line plot to display a data set comprising measurements taken in halves, fourths, and eighths of a unit, and we will determine the median, mode, and range of a set of data. All right, so I want to go over what data is first. So this is an example of data. So you have 21 students that were asked what their favorite fruit was. 7 students said apple. 4 said banana, and 10 said orange was their favorite. So data is basically items of information. So it could include facts, numbers, or measurements. Okay, so taking data, taking measurements, taking facts, taking numbers, okay? And then you have a line plot. We talked about this yesterday. So line plot, a horizontal number line that uses markings such as an X or a dot to show data points above their values on the line. So once you've collected data, you can then put the data into a line plot to kind of show what the data shows us, basically, okay? So for this example, it's number of students and the number of books read this month, okay? So the data has been collected. All right. So yesterday we talked about student book page 237, swimming pools. So let's talk about some of the things that we may notice about the line plot that was created. So one of the things I noticed is that no one spent the whole 3 hours in the pool. I also noticed that lots of kids swam between 1 and 2 hours. Okay. 4 kids were only in the pool for an hour. So when I go to the actual hour mark, there were 4 kids that were in the pool for an hour. 6 kids were in the pool for an hour and a half. So when I look at hour and a half, whoopsies, I'm going to erase that and start over so that you're not... There we go. Sorry. Okay, so for an hour and a half, we have 1, 2, 3, 4, 5, 6 kids who were in the pool for an hour and a half. And sometimes some have the same number of kids. So 3/4 of an hour. So you'll notice that 3/4 of an hour right here has the same number as 2 hours right here, right? So they both have 2 X's, which means that there were 2 kids in the pool for that amount of time. And then the shape of the X's, if you notice, is kind of like a hill. It kind of goes up and it kind of goes back down. So you notice that a lot with line plots as well. So what we kind of want to do is think about how we might determine the total number of time spent in the pool by all of the children. So there's a couple of different ways we could do that. So we're going to talk about that on the next slide, okay? Okay, so how do we determine the total amount of time spent in the pool by all of the children? So here's one way we could do that. So the first 5 students spent 3/4 of an hour, 1 hour, 2 hours, 1.25 hours, and 3/4 of an hour in the pool. So how much time did they spend in the pool together? Okay, so one strategy that we could do to solve that is to add the whole numbers. So I'm just showing you just a small amount of all the kids, obviously. I'm not showing you every single kid. I'm just showing you one way we could actually solve it, but not adding every single one, okay? If that makes sense. So I'm only using 5 students as an example here. So one strategy would be to add all of the whole numbers and then add the fractions. So you have a whole number, a whole number, a whole number, okay? And then you could add your fractions in after that. So let's take a look on the next slide to see what that could look like, okay? All right, so you can see again that you have your whole numbers, which are right here. And when you add all of the whole numbers together, you have 4, right? Then you can add in your fractions. So you have 4 plus 3/4 plus 3/4 and 1/4. When you put those together, notice that they make another whole, right? Okay, so that's kind of how that one whole came about right there. So that's one way that you can do it to come up with the answer of 5 3/4. Again, by adding the whole numbers first and then adding the fractions, okay? All right, so here's another way. So how do we determine the total amount of time spent in the pool by all the children? Again, I'm just taking a small amount of the children just to show you an example of how you could do it, okay? So we have the same problem here, but I'm just going to show you another way to do it. So again, we have our 3/4, our 1, our 2, our 1 1/4, and our 3/4 again. Another strategy is to find nice numbers to put together first. So you could add 1 1/4 and 3/4, and that would give you 2 whole hours. Then you could add 1 hour and the 2 hours to that to get a total of 5 hours. Okay. After that, you could add the other 3/4 of an hour to get that 5 3/4 hours in all. So I'm going to go to the next slide because that sounds like a lot, doesn't it? When you think about, or when you hear me saying that, you might be kind of confused. So I'm going to show you what I mean on the next slide. Okay. So basically, when you think about the numbers that go together nicely, okay, when you think about 1 1/4 and 3/4, they go together nicely to make 2, right? Okay, then if I change colors here and I see that 1 and 2 go together to make 3, when I think about 3 and 2, those together make 5, and then I have this leftover 3/4 here that I add. And then I end up with my total, right, of 5 3/4. So think about those things that kind of go together first and then put it all together. Or you could add all the whole numbers and then all the fractions to figure it out all together, okay? All right, so I'm going to go over some definitions here, some new definitions, and then we're actually going to practice these, okay? The first one I want to talk about is mean. Now, we're not going to spend a lot of time on mean right now. That's something that you'll get into later on in math. We're going to focus more today on median, mode, and range, but I'm going to introduce mean to you anyway because it is important. So the mean is the sum of all the numbers in the data set divided by the number of data points. So what I mean by that is when we look back at our last slide, if you were to add all of these together and then divide by the total number of numbers, which would be 5, okay? So you're finding, basically that means the average. So mean, another word for mean is the average, okay? So if I were to take 2 plus 7 plus 7 and 8 to find the average, I could add 7 and 7, right? And that would be 14. 14 plus 2 more would be 16. And then 16 plus 8 would be 24. So if I added all these data points together, I would get 24. And then 24 divided by the total number of data points. There are 1, 2, 3, 4 data points. That would give me 6. That would mean that my average was 6, okay? So that's mean. We don't have to worry about mean, though, today. We're going to focus more on the other ones. So then we have median. Median, is the middle value of an ordered set of numerical data. So in a set with an even number of data points, the median would be the average of those 2 points. So if you look at this, we've got 1, 2, 3, 4, 5, 6, 7 numbers right here, okay? You'll notice that the middle number is 8. However, if I had an extra number here, so let's say I had, instead of 7, I had 8 numbers, okay? And let's say that I had 15, and then I went to find my middle numbers. I would kind of go, okay, ooh, and luckily, this time around, I ended up with 2 8s. So then the median would be 8. In another case, if you had, let's say, a 5 and a 6, your median would be basically 5.5 because it's halfway between 5 and 6, okay? Now let's talk about mode for a little bit here. So mode is the value or values that appear most often in a set of data. So there may be no mode, one mode, or multiple modes in a single set of data. In this case, the number that occurs the most is 11. So the number 13 could also appear twice, which would mean that you have two modes, 11 and 13. But in this case, 11 occurs the most, so that is the mode. So mode means most, okay? And then finally you have what is called a range. So a range is simply, and we talked about this yesterday as well, the difference between the greatest value and the least value. So if your greatest value is 13 and your least value is 4, the range of values would be 9. You would take 13 minus 4 to get 9, okay? So that's how I would find the range. Okay, so now I'm going to kind of take all of these things I just talked about, and I'm going to break them apart a little bit for you to make it a little more easy to understand. So let's pay close attention to range for a moment. So remember, we just talked about it, but range is the difference between the greatest and the least value, okay? So if I'm finding the greatest and least value here, I know that the greatest value for the data from yesterday was 2.5. And I know that the least value of data was half. So if I take my greatest value minus my least value, I end up with a range of 2 hours. Okay, that's how I would find range of the data that we collected or that was given to us yesterday. Okay, so that's range, greatest minus least to find that range. Okay, now let's pay closer attention to mode for a minute. All right, remember that mode is the value or values that appear the most often in a set of data. So there may be no mode, there may be one mode, or there may be multiple modes in a single set of data. So mode is really easy, okay? Mode is easy. It's the one that happens the most. Mode is most. So think about the number that occurs the most. Again, mode means most often. So when you look at this mountain of data that we have here, you can see that the number that occurs the most is 1.5 because it has the most data points. So for 1.5 hours, the most number of people were in the pool for 1.5 hours, okay? We still have our range at the bottom, remember? So we have our range was 2 hours, and our mode is 1.5 hours. That was the number that occurred the most, okay? Mode, most. Mode, most, all right? And then finally, let's pay close attention to median for a minute. Median is the value that is in the middle. All right, now for this one, it gets a little tricky. And what I would probably do if we were in the classroom together for this one is I would actually take all of the data points, okay? Which this seems like it would take a very long time, but the best way to do this is to line them all up from least to greatest in a line, okay? So what I would actually have you do if we were in the classroom is I would take all of our data points. So I would put half, and then the next one we have was 3/4, and 3/4 occurred twice, okay? And then we have 1, and 1 occurred 4 times. 1, 2, 3, 4. And then we have 1 1/4. That also occurred 4 times. So 1 1/4, 1 1/4, 1 1/4, 1 1/4. And we have 1.5. That occurred 6 times. 1.5, 1.5, 1.5, 1.5, 1.5, and 1.5. Then we have 1 3/4. That occurred 3 times. 1 3/4, 1 and, whoopsies, I'm sorry everyone. 1 3/4, 1 3/4. Then we have 2, and that occurred twice. 2, I'm going to run out of space. Oh no. Then we have 2 1/4. I'm sorry, everyone. That occurred one time. And then we have 2.5. I was hoping this would all fit on a line, but it didn't. Okay. Now what you want to do here to find the median or the number in the middle is you would actually have to cross things out as you go. And the way I would recommend doing that is simply like this. 1, 1, 1, 1. 1, 1, 1, 1, 1, 1, boom, 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 boom. And you just keep going until you end up with, now in this case, notice how we have 2, right? And they happen to be the same number, which is perfect because when that happens, I don't have to find the average of the 2. I just automatically know that my median is 1.5 because it's the number that's in the middle, okay? So that's how you find median. So they did it the same way that we would have done it, but they just put slashes through. But I wanted to show you that one of the easiest ways to do it is to literally line up all of your data from least to greatest, every single data point, and then you just start at the outsides and move inside until you get to the middle or the one in the center, and that is how you find the median, okay? All right, I know, and sometimes that can take a little bit longer, and that's okay, but that's how you find the median, all right? Okay, so let's talk about student book page 237 from yesterday, all right? So it says, complete the line plot that Ben started using the data from the chart. So you can see that here are the answers that you were literally just looking at, okay? So you should have all of this data filled in. If you don't, though, take a minute to go ahead and fill it in. So for above half, you should have 1x. Above 3/4, you should have 2. Above 1, you should have 4 x's. Above 1 1/4, you should also have 4 x's. Above 1 1/2, you should have 6 x's. Above 1 3/4, you should have 3 x's. Above 2, you should have 2 x's. Above 2 1/4, 1 x. And above 2 1/2, 1 x. Okay? So for number 3, it said to calculate the total amount of time spent in the pool by the first 5 children. Boys and girls, I actually already did this for you earlier, in case you didn't realize, okay? So what I did was exactly what I said. This is what I was telling you there were 2 different ways you could do it, where you could take the whole numbers and add those together first and then add your fractions, or you could take those nice ones that work well together and add those together, so and then you would add your fractions. So you can see that here they took the nice numbers, 1 1/4 and 3/4, and that equals 2. Then they took 1 and 2, and that equals 3. Then you already have 5, and then you just add that extra 1, and you end up with 5 3/4, okay? So then it says to complete the following using the line plot above. Circle and label the minimum and maximum amount of time spent in the pool. You should have circled half was the minimum amount of time spent in the pool, and 2 1/2 was the maximum amount of time spent in the pool. So check. For 4B, determine and label the range or the difference between the greatest and the least value in the data. The range is 2 hours, and we did that a little while ago, right? You take your biggest number, 2 1/2, minus your smallest number, half, and you get 2 hours. So the range was 2 hours. Okay, check. C, find the mode or the value that appears the most, okay? To find the value that appears the most, you basically want to look at the peak on your, data point, right? Your line plot, and notice that, oh, well, the number that occurs the most, it has 6, so 1 1/2 hours, all right? So moving on, check. And then finally, find the middle value, and I just did that with you on the previous slide, and that was 1 1/2 hours. So that is how you do mean, median, mode. Well, actually, you didn't do the mean, but median, mode, and range, okay? And I wanted to go over that with you in case some of you might have felt a little bit frustrated doing that, okay? I never want you to spend way too much time doing your work. So if for some reason you find that it's taking you a very long time, just shoot me an email and say, Mrs. Sanders, I got frustrated, I worked really hard, I'm done, and I will be totally fine with that. And that's why I wanted to go over this slide with you. Okay. All right. So now I want you to turn to student book page 239. All right. Student book page 239. So we have the swimming contest. 16 of the kids who came to the swimming pool fundraiser had a contest to see how many laps they could each swim in 5 minutes. All right. We have Melissa, and she swam 4 3/4 laps. Okay, I'm just going to highlight what they did. We have Robert, and he swam 5 1/8 of a lap. Craig, who swam 5 1/2 laps. Tristan, who went 5 1/2 laps as well. And then we have Ben, who went 4 1/4 laps. And then we have Rachel, who went 4 7/8 of a lap. Okay. Then we have Bridget, she went 4 1/4. Then we have Catalina, who went 5 7/8. Tamara, who went 4 1/4. Henry went 4 1/8. Kim went 4 3/8 of a lap. Ryan went 5 laps. Jason, not Jacob. Jason went 5 1/4 laps. Natalie went 5 3/4 laps. Kelly went 5 laps. And then Riley went 5 3/8 laps. Okay, now it says to enter the data on the line plot. Okay, I'm going to go ahead and do this. Now, as I'm doing this, I want to make sure that I'm checking it off as I go, because if I don't check it off, I might get confused and put the same thing twice, or I might forget to do one. Okay, so I'm going to start with Melissa, and that's 4 3/4. So do this with me, okay? I want to find 4 3/4. 4 3/4. And 3/4 is the same as 6/8, okay? So we don't have 4 3/4 on our actual chart. We have 4 6/8. So I'm going to actually write that is, oh my goodness, Mrs. Sanders. Wow. 4 6/8. That is the same thing as 4 3/4, okay? So I'm going to go ahead and put that above my 4 6/8, which is right here. Okay, and then I'm going to check off Melissa. Okay, done. Now I've got Robert, 5 1/8 for Robert. So I'm going to go ahead and put this above 5 1/8, and then I'm going to give Robert a check mark. Can you do that with me as well, please? Then we have Craig. Craig is at 5 1/2. Now, when you look down at the bottom here, we don't have 5 1/2, but we do have 5 4/8. So I'm going to put that's the same as 5 4/8. And then I'm going to go ahead and put an X above 5 4/8. Okay? All right, then we have Tristan. Tristan went 5 1/2 as well. So I'm going to also write 5 4/8. I'm going to put another X above 5 4/8, and I'm going to check off Tristan. I, again, am making sure that I am doing this the proper way because I don't want to forget someone. So now we're on to Ben. Ben went 4 1/4, okay? We have to think about how many eighths that is. Boys and girls, that is 4 2/8, okay? So I got to find 4 2/8, which is right here, and I put an X. And then I'm going to check off Ben. Now we've got Rachel. Rachel went 4 7/8. Rachel is right here at 4 7/8. Boom. All right, moving on to Bridget. Bridget went 4 1/4. Remember that 4 1/4 is the same as 4 2/8. Okay, so I'm going to put another X above 4 2/8. And then cross off Bridget, or check Bridget off. Now I'm on Catalina. Catalina went 5 7/8. 5 7/8 is all the way over here. Put an X, check off Catalina. Okay, moving on to Tamara. Tamara went 4 1/4. So remember that 4 1/4, we've seen that one a couple times. That's the same as 4 2/8, okay? All right, 4 2/8, that, my friends, would be right here, okay? So then we check off Tamara. Then we've got Henry. He's 4 1/8. So that one's right here. All right, check off Henry. Then we have Kim. Kim went 4 3/8. So Kim is right here. Check off. Then we have Ryan. Ryan went 5 laps. Then we have Jason, who went 5 1/4. Remember that 5 and, 1/4 is the same as 2/8. So this would be 5 2/8, okay, for Jason. So we got to find 5 2/8. That would be right here. And check. Then we have Natalie. Natalie went 5 3/4. 3/4 is the same as 6/8, okay? So this would be 5 6/8 for Natalie. And that would be right here for Natalie, okay? And then we have Kelly. Kelly went 5 laps. And then we have Riley. Riley went 5 3/8 as well. All right, and Riley is right here. Okay. All right, so we've officially put everyone on the line plot here. So now it says, how many students swam 5 1/8 laps or more? Well, I've put the data in there with you, my friends. So now I want you to see if you can answer the rest of these questions on your own. So using the data that we have put in here, can you answer these questions? How many students swam 5 1/8 laps? 5 1/8 laps. Now I want you to think about it very, very carefully, okay? So if they swam 5 1/8 laps, they also swam something less than that as well, right? So don't just count that one student there. Think about how many all together, okay? And then, how many students swam fewer than 5 laps? Less than 5 laps, okay? Count them all, okay? So number 2, this one is kind of tricky, I'm going to tell you. Number 2 is a little bit tricky. Think about that one very carefully, okay? All right. Okay, and then how many students swam fewer than 5 laps? That one's a little easier. If you have any questions, please email me. Number 4, what is the mode of the data? All right, this is the one where you're looking for. Remember that mode means most. What occurs the most? You are looking at the peak, boys and girls. And then finally, find the range of the data. Remember, that's the difference between the fewest and the most. Find the most and the fewest and subtract and show your work, okay? So I want you to finish this page for me, okay? All right, so I put the data in for you. Now you finish it. And then for the snail race, Cindy had a collection of snails, and she wanted to see which snail could travel the farthest in 1 minute. Below is a table showing the distance each snail traveled, okay? So then you're going to complete the line plot below and display the information shown in the chart, and then answer the questions. I'm going to do one plot for you, okay? So when I'm looking at snail A traveled 4 1/4 inches, okay? So to find 4 1/4, I'm going to tell you right now that that is the same as, so first you want to put in your data points, right? So your data points, you've got to put this in. This is going to be 3 1/8. And then you have 3 2/8, 3 3/8, and you got your 3 4/8, 3 5/8. Sorry. 3 6/8, 3 7/8, and obviously 3 8/8 would be 4, right? And then you've got 4 1/8, 4 2/8, 4 3/8, 4 4/8, 4 5/8. I'm sorry if this is hard to see. 4 6/8, 4 7/8, and so on, okay? I'm going to plot A for you, 4 1/4 inches. That is the same as 4 2/8, which would be right here. And I'm going to check off A for you, okay? I want you to plot the rest of these. So you plot the rest, and then you're going to find what is the shortest or minimum distance, what is the longest or maximum distance. Then you will find the difference between the longest and the shortest. Then you're going to find which distance appears the most. So you're going to find the mode. And then you're going to find which distance is in the middle of all of the measurements. Okay? So you'd want to line them up from shortest or least to greatest and then find the one in the middle. All right? So those are the 2 student book pages that you're going to do. Then you're going to complete Home Connection book page 123, which looks like this, and Home Connection book page 124, which is a review, okay? And that is your lesson for today, boys and girls. Remember that I'm so proud of you. You are working so incredibly hard. I miss you all so much, and just keep up the awesome rock star work, okay? Talk to you tomorrow.